here we've got two copies of the same code base. It's a simple order app. We've got our command, our handler, we've got our domain objects, we've got a repository here, we've got the root, we've got a test folder with some test projects in it or test files in it. And we want to enhance this application a little bit. And we're going to give the exact same code or the exact same command to both code versions. We're using the Claude AI agent here to add that command. We just want to add a cancel order to the orders module with the tests. And we'll go ahead and kick that off here. So we're going to run that both. And we'll give it a couple minutes here to work through it and see what it comes up with. And as we let it spin through here, we'll see several things come through. And you'll see that in both of them, I've got the auto mode engaged so that it's not prompting me for a bunch of stuff and not having to cycle through things, just letting it run through. And we'll see what it comes up with here for each of these. And probably the best way to look at that is we'll look at the Git changes here. Open up the Git tab in both. So we can see the changes that are generated by these two instances. And you'll see here when it does finish up here, that's going to come up with two somewhat different approaches to adding this new command to our code base. And we'll talk through what the reasons for that are and why each of those comes out just a little bit differently from each other. Let's see here. We'll give it just a couple more moments here. You can see the one on the left's writing some code for us here. And the one on the right should start that here in just a moment as well. Okay, the one on the left has wrapped up. And you can see here it came up with 4 files that are either updated or added. And actually it hasn't really added, it has created a couple here. So we've got a cancel order command, a cancel order handler, and some tests, and made an update to our order domain object. And looks like the one on the right here is getting pretty close to done. And that's wrapped up here. So let's go over here and see what it came up with here. And it looks like on this side it also came up with 4 files that were added or changed. Now as we look at the output for these two tests, in this particular case we're going to see that they're almost identical. The command was identical, the test files were identical, the update to the domain object of order here was identical on both of them pretty much. Other than some white space kind of things. The main difference here was between these two handler code files. We can see in one particular case it's returning an error, and the other one it's returning result.invalid. Other than that, it's almost identical in what it generated. That's not always going to be the case though, and that's one of the things with AI is that it's very inconsistent. I've run this test 4 times now, and each time the one here on this side, on the right side, has come up with a different solution. Sometimes it's very close to the one I've got here on the left. Sometimes it is completely different from the other one. In one particular case it created all new like MVC controllers, and in another case it created an API controller. It's just very inconsistent in the result that was generated in each case. The whole purpose of this video is to talk about why and how we can control that and make sure that what we get is consistent and gives us pretty much the same thing that we expect time and time and time again. And the way that happens is through instruction files. My name is Barret, I'm with NimblePros, and let's go ahead and get into it. All right, so this video is the first one in a series of videos on AI agents and how to make them better, how to work with them in a more effective manner. And this series goes hand in hand with a series of blog posts that we posted to the NimblePros blog, talking about AI agents and how to make them effective. Taking them to the next level. And this video, as I mentioned, is the first one in the series to kind of go hand in hand with those. So if you want to check out the blog post, you can do so on our NimblePros blog. But for now, let's get into the first part here, which is talking about AI, or talking about instruction files for AI agents. So here's where we get to the root of it. AI agents have no memory. They don't know your code base. They don't know conventions. They don't know what it is that you went through with them the last time that you used the AI agent. Every time that you start a new conversation with an AI agent, it has no memory of any of the conversations that came before it. And if you don't spell out explicitly what it is that you want the AI agent to accomplish, the result that you're going to get is going to be inconsistent. It's going to be random, really. And those guesses that it comes up with change from request to request. It's not that the AI agent is bad at what it does. It's just that it's starting from zero every single time. And the way that we overcome that is by using instructions files. So compare it to bringing on a new developer onto the team. It doesn't matter whether that developer is a new developer fresh out of college or boot camp or whatever it might be, or whether they're a senior developer. There is a ramp up time that occurs where you have to explain to them what your code base is, what your team standards are, what it is that you want them to accomplish when you give them a task to work on. And if you can imagine having to explain that to them every time you want to give them a new task, the way that we overcome that, whether we're dealing with human coders or AI coders, is we write it down. We make a reference document so that we never have to repeat ourselves each time. And that's exactly what an instruction file is. Out of the box, an AI agent is a generalist. It doesn't, as I said, it doesn't know a lot about specific things. It knows a little about a lot of things. And some of that knowledge is stale. They spend months or years training these AI agents. And by the time that they're done with that, a lot of the information that they have been trained on may be out of date. You look at how fast languages and libraries iterate. .NET, there's a new version every year. There may be patches and updates throughout the year. If you look at libraries and other things that you use, how often do you have to update your NuGet packages? Because something changes. Well, over time, all that knowledge that a particular AI agent has becomes stale. And the way that you help it overcome that is through these instruction files and through other things that we'll get into in some of the later videos as I go through this series. But right now, what we're talking about is these instruction files. How do you turn that AI agent or a new developer into, someone who understands what your standards are, who understands what your code base is all about, and we do it by giving them this file to work with and to use as a starting base. And it's all kind of tied to the context, which we'll get into a little bit later. But if you understand how AI agents work, is that every time you make a request to an agent, it includes a bunch of context information. It's just not the prompt that you provided. It can also include a lot of information about things that you talked about in the same conversation previously. And it can also include these things like instruction files, which give it general knowledge, because each time that you make that request, again, you're starting from zero. So by having these instruction files, by giving it this baseline of knowledge to work from, each time you make that request, you're going to get more consistent results in the code that's generated by that agent, and code that's going to match what your standards are and what your project is. So depending on which coding agent you're using, there's going to be different places that it looks for. So with Claude, it looks for this Claude Markdown file, and there are various levels, and we'll talk about where these go in a minute. Codex, which is ChatGPT's agent, it looks for the agent's Markdown file. GitHub Copilot looks for a Copilot instructions file. But it also has one advantage over Claude and Codex and the others, is that it will also honor a Claude file or an agent's file if it finds those files in the project. That's one advantage that Copilot gives you over some of the others. And then Cursor uses these rules files that are scoped by Glob, or basically a pattern match to what it is that you want it to work with. And that's a little more in depth, and we're not going to go into the depth of that here, but just understand that you can create different rules files for Cursor that can be scoped to a specific area. There's also various tiers. So with Claude and with some of the others, there are various levels of these Markdown files that you will create. For instance, you can have a global file, which goes in your home directory. This is where you would put things that are specific to you personally as a developer, things that you want it to work with or want it to do as part of how you work with it, but not necessarily something that you want to share with the entire team. So maybe you have a certain file somewhere on your so a reference file that you would use somewhere on your system. You would tell it where to find that in that global file, or personal the personal way that you work with things and how you want to approach things. Do you want to run the tests after every check-in of code? Do you want to create a new branch before you start with anything? Anytime that you make a request, those kinds of things that might be personal to you, you would put into that global file. You can also put in a file at the base of a project, and this is where you would put things like your team standards, the conventions that you use, your architecture, things, how it structures the application, how it, where it should put new things when it's creating code. That kind of stuff would go into the global project, or not the global, but into the project level file. And then if you have instructions that you want that are specific to a particular part of the application, then you would put that into the directory itself that's part of that is that part of that application. For instance, if you're using clean architecture and you want to put in instructions that are specific to your data domain, how do you work with Entity Framework? How do you create data objects? What kind of global standards do you want for those data objects? That kind of stuff. That would go into a Markdown file that is put into that directory. And then when these AI agents are working with the various blocks of code, it will only use those parts, or it will only use those standards that are in those Markdown files that are in those directories that it's working with. And one of the reasons that you would want to do that is, one, you don't want to send everything every time, because all of these instruction files get included in the context, which is part of the request that's being made each time you make a request to the AI. So you want to make sure that anything that is specific to that one piece of the application that isn't necessarily part of the rest of it, you want to put it into that particular directory in the Markdown file that goes in there. And the reason that you do that, again, is because it's including all of this information every time that it's making a request. It's part of the context. And context, the bigger the context, the more tokens that you use. And the more tokens that you use, the more expensive it is to work with that particular AI client. There have been constant stories recently about companies that are realizing that AI costs a whole lot more than they were expecting it to. As they're pushing it on their developers and on their teams, they're using up all these tokens, and they're running out of tokens, for their account, and it's becoming very, very expensive. Well, the more text that gets included, and we'll talk about the kinds of ways that you would structure your files in a bit. But the more text that gets included, that's the more context, the bigger the context, and the bigger the context, the more tokens that you're using. So you want to make sure that You're only including in each of those files the things that are specific to that particular need. You definitely don't want to repeat yourself across the levels, as it says there. So, if you have, like I say, if you have something that's specific to the data domain, put it in a file in that data directory. Don't put it at the project level. Don't put it in your global level. So what kinds of things do and don't belong in these instruction files? So you definitely want to include things that are about your architecture, about the domain boundaries, about the abstractions that you're using, about how you work with the various libraries. Tell it which libraries you want to use. Your preferred packages, as it says there, and ones that are banned. If you want to make it specific to say, okay, we're going to use fast endpoints and not use minimal APIs or MVC. Or the old school web API or whatever it might be, specify that in like your project level one, and you'd say, okay, we're doing that here. This is how we structure it. This is where each of those pieces of the code go, and all that kind of stuff. Other things that you include, things like how to build and run the application. The same kind of instructions that you would give to, like I say, a new developer that you're onboarding, so that you don't have to repeat it every time that they're in there. So you just hand this document and say, this is how you do it. This is where you look for things. This is what you work with. And these are the libraries that we're using. These are the libraries you're not supposed to use. All that kind of stuff. That all does go into those instruction files. The kinds of things that you don't want to put in there, because you should treat these instruction files the same way you would code. So you don't put secrets in there, because it gets these instruction files get checked in with your code. They get included in your repo. So you definitely don't want to be including secrets. Treat it the same way as you would your app settings.json file. You want to keep it short and to the point. Like I say, all the information that's in these instruction files gets included in the context with every request. So you don't want to be verbose. You want to be very succinct, very to the point. Keep it short and simple. There's a skill that's out there that's called Caveman that helps to reduce the context on the responses by telling the AI, speak like a caveman. So it's very short and to the point and simple speech. You kind of want to be the same way in the way that you write your instruction files. You want to be very short, simple, to the point. Don't repeat yourself. Don't go on and on and on. You also don't want to include anything that the AI agent already knows. You don't need to tell how to use a class, how to create a class, how to write a for loop or a switch statement, or any of this kind of general knowledge stuff. You don't need to include any of that. The AI agent is a very good generalist, so you don't need to include that stuff. Also, you don't want to include anything that's out of date, anything that is that says, okay, we used to do something this way, but we don't do that anymore. Don't include that information. That's not important. The AI agent doesn't need to know. It only needs to know what you're doing right now. So anything that you used to do, anything that you might do in the future, don't put that into these instruction files. It doesn't need to know. So here's a quick example of what a real instructions file might look like. Like I say, these are markdown files, so they're plain text. You would include things like your architecture design, your coding conventions, how to test the application, how to write the test, how to name the test, tell it what not to do. So, say do not use MVC controllers, that kind of stuff, and how to build and verify the application. You would probably also want to include instructions on when to do the testing. So, if it's your standard to make sure you run all the tests locally, to do a clean build and test before you check in code, then include that as part of your instructions. So like I say, treat them like code, not like documentation. Documentation, stuff you shove into SharePoint or Jira or whatever, and it never gets looked at again. That's not how you should treat these files. These files should be treated as living, breathing documents that are like your code, that are as important as your code. And if standards change, if the way that you do things changes, if the libraries that you're using changes, make sure you're keeping up to date on that and updating the file. These code files, these instruction files, when you create them, like I say, it should be treated like code. So you should do a code review when you create these or make changes to these files. so that people can look at them and say, okay, yeah, that makes sense. That is correct. That is an appropriate change, that kind of stuff. And like I said, they're living, breathing documents, so you should review them at the very least, every 6 months. Anytime, you should also review them anytime that you're onboarding somebody, or if you're starting a new project or anything like that. Anytime there's a major release. So, for instance, if one of the libraries that you're working with has a major release, review that, review how it's addressed in your instruction files. Update it to be appropriate to the new versions that you're using. So, if there's a new feature and you want to make sure that new feature is implemented and that it's not doing things the old way, make sure you're updating the instruction files to say, hey, use unions or whatever it might be when you're writing your code. And anytime that there are major architectural changes, you should also do a full review of the instruction files in the project to make sure that nothing is now out of date, like I say. So, as it says there, stale rules are worse than none at all. So you always want to make sure it's keeping up to date. So let's go back and look at this code just a little bit here that we generated for the application. So as I say, in this particular case, it came up with stuff that was pretty similar to what it did with the instruction files, and that's one of the key things to remember about AI agents is that's not always going to be the case. It could come up with something completely random because as we know with every language, there's a dozen different ways to do anything, and the way that the AI agent does it won't necessarily be the same from time to time. I can make, like I said, make that same request 4 times and it generated 4 different types of code without these instruction files. Whereas this version of the application that had the instruction files generated almost identical code every single time. It always made the update to the order file. It always created this command and handler that were in the same pattern as the one that already existed, which was this place order command and handler. Like for instance, the last time that I did it, it made a bunch of changes to the order interface here. It added a whole function here of how to interact with the domain or with the repository kind of thing. So it could be completely random, and those instruction files help you to make sure that it's not as random. You still might get some randomness. I mean, it's an AI agent, and it's the same as working with a a human developer. What comes out is not going to be the same. I might write something completely differently today than in the way that I wrote it a week ago. And that's just how both we are as developers and the AI agents are the same, and sometimes even worse. So let's look at the AI parts of this here. So we'll start with the folders that are here. So Claude, when it runs, it creates the settings files. You can ignore that for this. But Cursor, so we've got the rules here, and it creates these markdown files and uses a .mdc for its files here, but it's really the same way. So as I mentioned, Cursor uses these globs, which are basically pattern matching. So saying, okay, anything, this file here applies to anything that's in the source directory with, that's a C# file, and it's in the domain project here, or the domain thing. So this particular markdown file would apply to anything that is in this domain section of the project. So any of these C# files that are in here, it'll apply these rules when it's working with it. And that's the way that Cursor works. It's a bit different than how any of the other ones work. So it's just something to keep in mind if you happen to use Cursor. GitHub, as I mentioned, it creates this Copilot instructions file here. And that's what it looks for first. And if it'll kind of prioritize this file over any instructions that might be conflicting in other files. But it will also honor anything in an agents file or anything in a Claude markdown file as well. It'll look for those and it will use those files. I don't believe it will use the global one, but anything that's in the project folders or the project structure, it will honor those. So if you've got an agents in a Claude file or anything like that in here. So the documents folder here, go to the source folder. So if you go down here, for instance, look at the agents one that Codex uses as its primary one. You can see the instructions that I've had in these are fairly similar from version to version. So for instance, if I've got my CLAUDE and my agents, they're a bit different here, but it's generally the same idea. So you're providing instructions in here. And for instance, this one says, okay, follow the instructions that are in the CLAUDE Markdown file. And you can do that as well. You can tell it to look at other Markdown files that are anywhere in the project and say, follow the instructions that are in there just the same as if it was in here. So that's a good way if you want to write in support for multiple agents. That's a good way to do it. You can start with a base file, and then just tell all the other files to reference that file as well. So that's a great way to split up your instruction files to be cross-platform supportive. So you can do that. And then this main one here, the CLAUDE file, so you can get a good idea of the kind of things that you would put in here and would not put in here, or that you would put in here. I'll show you an example in a second of things not to put in there. But for instance, this one, it's broken down into sections here. I've got my solution structure. It's telling it where to put the source documents, where to put diagrams and documents, things like that. Architecture is specifying, okay, we're going to do modular monolith. If they're shared types, this is where they will go. Domain logic goes in the domain layer. Don't put any of your data stuff or HTTP endpoints or any of that kind of stuff in your domain logic. You've got an application layer and things like that. We're going to use mediator command query handlers. We're going to use the Ardalis result for our responses. We're going to use guard clauses for anywhere that we need to validate incoming requests, that kind of stuff. Prefer sealed records over value objects, or for value objects. Implement aggregate root on those. So any of these instructions going on down through here, every handler must have unit tests. Use the arrange act assert pattern. So for instance, if we come down here and to our tests, so if I look at here, say this is the naming structure, and method name, condition, expected result. You're going to use arrange act assert with a blank line in between each section. If you come down here and look at the actual test file, as you can see, it's the function call, the result kind of thing. Here's my arrange, then I've got a blank space, then here's my action, then I've got a blank space, and then here's my result. And if we look down through here, you can see that it has followed the correct pattern for each of these. So I've told it this is how I want you to structure my tests, and it has correctly implemented those as a result. Also include instructions on what not to do. Says do not use MVC controllers. I mentioned that the other one here, actually, one of the rounds that I did with that, it actually did create MVC controllers instead of using the other pattern because it did not have this instruction here. Do not add NuGet packages without a comment explaining why. Do not use var when the type is obvious or isn't obvious. Sorry. And if I go down here and look through the application here, you're going to see it's using var in pretty much all these cases, but that's always because it's always obvious what it is that's on the other side. So this is a handler. This is a handler.handle kind of thing. And then build and verify. Now this is an interesting one. So I'm telling it to do a build and verify, but if I go here and look at the response that came in from CLAUDE, not that one. There we go. So if we look at what it went through here, you'll see this repo has no solution CS project. Per the README, it's a convention sample, not a runnable product. So I couldn't run the .NET build and test as CLAUDE requires. So it understood that was part of the instructions. I told it, as part of this, you need to run .NET build and test. Well, it looked at that, and then it also looked at the README file in the application and said, hey, this isn't actually a full project. This is just some sample demo files. So I can't actually do that. So it told me, hey, I can't do this. You instructed me to do it, but I can't do it because it's not actually a full solution. Let me know if you'd like me to turn it into an actual solution that's runnable. So you'll see it trying to comply with the instructions that are there. But if it can't, it'll tell you that it can't, and it'll tell you why it couldn't. So that's always a thing. For instance, always run tests before marking a task complete. Well, it couldn't run the test, so it couldn't actually mark that task as complete. And you can see here in the summary, the recap here says no runnable project exists. Let me know if you want a project file scaffolded. This will be the next step. So I'm not actually done with the instruction that you gave me. This is the reason why. Here's what I suggest that we do to fix that. Let me know if you want me to do that, kind of thing. So it's actually very handy with that kind of stuff. And you can see if I go down here into the README, there we go. The code here is intentionally minimal and exists to give a convention a copy, not to be a runnable product. So it saw that as part of the stuff that was in the README. It looked at that and said, hey, I can't do what you want me to do. So that's a very simple and straightforward kind of example here. So let's look at kind of things that you would not want to include. So I mentioned don't be verbose, don't be wordy. This one example here, this is a bad example. It includes this big long block of stuff here at the top that really has no meaning, it has no usefulness. It's just blabbing on about nothing in particular. You don't need to provide in specific or basic syntax instructions. It knows how to write a for loop. It knows how to create a class file. You don't need to provide instructions for it to do that kind of stuff. You don't want to include any secrets. So your database connection strings, your API keys, don't put those in your markdown files because, like I say, those are secrets. Those are things that should be kept in like Key Vault or in your environment variables in the server or whatever it might be. You don't want to put them in here, and that because, like I say, this gets checked in. It's treated like code, and you wouldn't put that stuff in your code, right? Okay. Don't include stuff that is what we used to do or what we might do in the future. The AI agent doesn't care. And it doesn't need to know about any of that stuff. It doesn't need to know how you used to do things. That might be useful information for a developer for historical reference purposes or whatever it might be, or so that they understand what you might be doing in the future. But the AI agent doesn't need to know that. So don't include those in your instructions files. Keep all that stuff out. Keep it short, keep it simple, keep it to the point, and keep it on task, on target. All right, so just a couple of things to talk about as we wrap up here. Remember, context is your job. Those agents don't have a memory. They don't remember what you included in the last command. They don't remember what you included in a command a week ago. So all that information about your standards, about all that kind of stuff, it all needs to be in those instruction files because those get included with every request. They're part of the context. And if you keep them in there, then the response and the result is going to be very consistent. It's not going to remember that you told it 5 requests ago, this is how you do this kind of thing for this particular project. You need to put it into these instruction files. Don't repeat yourself. Know what kind of content goes in which files. Your personal standards go in the global file. Your team standards go in the project level file. The things that are specific to a particular section of the code that aren't global to the project go in the various directory files. And you can get as detailed or as not detailed, but as separate as you want to be. You keep it very specific. You can drill down several levels into the code, and if there's something that's an instruction that's specific to that one particular folder that's 5 levels deep in your code, then put it in there. Don't put it in the global project file. Keep it very short, keep it clean, keep it simple to the point, and make sure that you're reviewing it regularly like code. Treat it like code, because it really is. It's code. It's part of the instructions, and it should be treated that way. So that's it. And this is, I mentioned, this is the first video in a series on AI agents. This kind of goes hand in hand with some blog posts that were posted to our NimblePros blog. And if you want to see the full series there, you can go out there to see it on the blog post out there on our website. And up next, we're going to be talking about, in our next video, we're going to be talking about skills files and how that can, take, the basis that you've created here with your instructions files and kind of take it into the next step. So, the instructions files give those general standards. Skills files will teach the AI agent how to do a specific task. So that's what's coming up next. And thank you for your time. Have a good day.